ball itself has its own energy, or life force, if you will. Its natural environment is in the hole. So why don't you send him home? His bags are packed. He's got his airplane tickets. Bring him to the airport. Send him home.
Send him home. I just send him home. It's time to go home there, ball.
Son of a ball, why didn't you just go home? That's your home! Are you too good for your home? Answer me!
Virginia, put out a press release concerning Happy Gilmore being thrown off the tour. I want to see a draft by 6 p.m.
You're right. He was out of line. His behavior is completely unacceptable. But you know, golf has been waiting for a player like this. A colorful, emotional, working-class hero.
I will not tolerate behavior like this. Gilmore is gone.
I just got a call from the Dallas Open. Their phones have been ringing off the hook with people who want to see Happy. They just sold out.
Already?
I know, he's a little rough around the edges, but let me work with him.
So we talked about the mini golf task last lesson, but I'll just go through a few more things to make sure it's perfectly clear before you start. So as you can see on the screen, the task is to increase the profits for the mini golf course by making a difficult challenge or a difficult hole in each group. You've got a few requirements, so it must be A3, so the base of your golf course is A3 sized. It must contain a prism with your name and your hole number, so these will be available on the OneNote. I've listed all of the groups and what number you are per group. It must have a ramp in which the ball or the golf ball will roll down, so we're not hitting it, you'll place it on the ramp and it'll roll down into the course. As well as that, it needs to include a sand bunker, a water trap, and an obstacle of some form which is represented in the shape of a parallel, like a parallelogram, a quadrilateral, a rhombus, a triangle, and a kite. So all of the shapes that we've talked about in this unit. How you put them together is entirely up to you. If you want to make a windmill that the ball goes through, and it's made of a whole bunch of different shapes, that's up to you. That's a great idea. If you just want to have basic little blobs and squares all over the place that the ball will bounce along like a pinball machine, that's fine too. You need to have a fence or a boundary around the perimeter of the golf course. So the entire golf course, as shown in the picture on the screen, which is not a particularly good course, but it needs to have a boundary so the ball can't just roll off the course. The ball must not be able to pass directly into the hole. So you can't roll it down the ramp, and there's no possible way it will roll straight into the hole. That's going to be a pretty boring golf course. You need to calculate the following dimensions and use your calculations and the information on the table below on the screen to work out the cost of how much your golf course is. You need to calculate the perimeter of the mini golf course, so the boundary around your A3 page. You need to know what the length of the sand bunker is, the water trap, the obstacle, and anything else in your mini golf course. I need to know what the lengths of it are. You need to have the area calculations for the sand bunker, the water trap, and any obstacle. So if you build your crazy kite windmill, that's fine, but you'll need to calculate the area of that kite, each face, let's say. As well as that, you'll need the volume. So don't worry about surface area because we haven't covered that, but you'll definitely need the volume. So how much does each of your shape take up in 3 dimensions, which is its volume? And we're just using formulas that we've used in the measurement task already. Then we've got the volume of the prism and the ramp. So your initial ramp that you roll the ball down, we need to calculate the volume of that. So if you think about it, it's going to be a triangle on one side, and then we multiply the area of that triangle by how wide the ramp is, and that'll give you the volume. So that's a triangular prism if you look that up. And we also need the area of the grass. So this might be a little bit tricky. If you've got curves anywhere, that's going to make it quite difficult. So you need to approximate it, put little squares down somewhere to try and measure it as roughly as you can or as close as you can to a square. Or if you want to get really creative, use circles in sections to create a more accurate measurement of the area. So as I talked about before, if this is my golf course, and let's say my ramp starts in the corner and runs this way. So from that point, the ball rolls down. I'm going to say it hits an obstacle here, I want it to bounce this way, hits another obstacle, goes this way. There's a sand bunker or something that I'll put, hits that, and the hole will be here. So anything else on this course that is not an obstacle, is not water, is not sand, is grass. So I need to calculate the area of this. So what I talked about is I could just measure this as, oh yeah, this is a square, this is a square, this is a rectangle, rectangle, and measure all of those little rectangles and squares to find the area. Or for something like this section, I might say, well, let's measure this giant square here, work out what the area of my little circular pool is, and subtract it. And that'll give me a very accurate measurement in here of how much area of grass I've got. And that's worth a lot more marks. If you do this process, you're using more formulas, using your circles. We could use like a kite or something if you really wanted to. You know, that's where your extra marks are going to come. So if you're striving for that A or that B, this is the stuff I want to see. If you just want to scrape through and do the bare minimum, just use some squares, some rough calculations, that's fine. You're going to pass, you're going to do well. But if you really want the higher level stuff, this is what I expect.
When you're doing your calculations for the costs, let's take grass for example. If I calculate the area of my grass across the whole course and I find it to be 10 centimeters squared, for example, that's just an example of the area that your grass might be. It's probably not going to be a perfectly round number like that, but let's say it is. If grass costs $1.50 per centimeter squared, well, this is how much it costs per centimeter squared. This is how many centimeter squareds that I have. So I just multiply the two numbers. So the total cost is just going to equal, basically, for any version, we can say cost per centimeter squared times by how many centimeters squared. So this is how we do it for the grass, for the water, all these things. Find out what it costs per centimeter squared, which is on the table, and then just multiply by how many centimeters squared that you calculated we actually had. And that's all there is to it.
Even though this is a group task, everyone will hand out an individual folio task, and I want this to be tidy. I want it to be well organized. So for example, you would have your task. You would have mini golf on the top. You're going to talk about, the first thing I want you to write is, what is the aim? So this is in the actual challenge heading. It says to increase profits by increasing the difficulty of the course. That is what you need at the heading. Then you can talk about shapes or obstacles. And I want to see something that looks like, okay, I've got a rectangular obstacle. Its area, its volume is. Then you do, say, your water. Same thing. Area, volume. Do this for all of your obstacles. Obviously, you're going to have your ramp as well. Not the best drawing, but 3D ramp. Ramp. And I want area and volume of the ramp as well. Then, below that, you've done all these calculations. Then I want you to do costings. So you'll have a little table, and I want you to show the working out. So I don't just want answers. So I want you to say, so grass equals whatever per centimeter squared. Total grass equals whatever you calculate it. Therefore, cost of grass equals. And do this for all of the aspects. So for your grass, your water, your sand, all of those things like that, I want these calculations. So this is a general guide of what it will look like. The prettier you make it, obviously the more marks it's worth. If you've got better images, you've got more calculations, better descriptions, all of these things, that's going to be worth a lot more marks. In terms of building the obstacle course, I've got Mr. Belperio is helping us out today, and we've got cardboard available, we've got scissors, we've got glue sticks, and we've got sticky tape. If there's anything more elaborate that you need to use for the next lesson, plan ahead figure out what shapes you need, and when I come back, we can use hot glue guns and core flute, the more rigid plastic stuff, if we need it. But ideally, you should be able to build everything just out of cardboard with glue sticks, scissors, and sticky tape. Think about if I wanted to make a box out of cardboard. I could just cut a bunch of squares and stick them all together with sticky tape. It's not going to look great, but it'll work. Think about if I want to make a cube, the template is what we call it. What shape do I need to cut out to make a nice little cube that has overlapping tabs? Well, if this was a cube, we know it would have 4 sides in this direction and 2 sides in that direction. If I cut this out and fold all of these lines, I make a cube. But none of the sides will overlap, so I'd have to sticky tape every edge. However, if I cut little tabs on all of these sides, just like this, and this is something that you could probably Google if you just look up template for cube, template for cylinder, all of those things, you'll find images like this. So these little tabs here, if I just leave these on when I cut them out, when I fold it all up, the tabs will tuck in to these bits, and it gives me something to glue, so I create a nice little cube. An example of cutting my shapes, my templates, is if I cut this one out here, so you can see this is just a standard cross-shaped object, and if I fold this together, sure, I get a cube, but it's not going to be particularly nice when I stick it together, because you can see it has no edges to glue to, so I'm going to have to sticky tape every side together. It's just going to look like a big square of sticky tape, so it's not particularly great. So the tabs that I was talking about before is if I cut the same shape, but I put these little tabs on, so you can see where I've got the blue, these are little edges that I can fold up. So every piece has tabs, and again, you should be able to find a template or a bit of trial and error, and you'll figure out how to do this. Now if I've got my shape with the tabs on it, when I fold it together, you can see how, if I zoom in, I've got a nice little join there. So I've got this tab here that allows me to glue it. So when I put it all together, I can just put a bit of glue stick or even sticky tape on the inside as I make it, and I'm going to have a nice little seamless shape without a whole bunch of tape. So using this template with the little tabs on it is going to make it a little bit better. It's going to make it look better, but that's entirely up to you. If you can figure it out and you want to put the effort in, by all means, I recommend it, but don't spend the entire lesson just trying to make a single shape. It shouldn't take you that long.
Right. This one's very tough.
He's laughing, he's having a good time. Good for you. Yeah, laugh it up. Enjoy your night.
Come on, Happy, concentrate.
Hate that clown.
Easy. If you can't beat the clown, how you gonna beat Shooter McGavin?